startups. They're doing very interesting work. And in fact, I often get excited about the work that they're doing, particularly in the space domain. It's quite amazing, actually, the new ideas. There was a space conclave which I attended, and it was quite amazing, how far ahead they're thinking. So I think, it's too late for me, but for youngsters, I think it's still a lot of openings in the industry. So your skill sets, your young minds can be, applied there. Can we have her presentation now? Abhartana, please, TCS.
Good morning, everybody. So I take this privilege to be here today. Until about 2 years back, I was one of the students sitting amongst you. I have so many people, so many known faces with whom I have interacted during conferences when I was a student and a postdoc. So giving a brief introduction about who I am, I did my schooling and college from University of Calcutta. And after my master's dissertation at NRSA ISRO, I had joined CESI, IISER Kolkata for my PhD. And from there, I had moved to IUCAA, where I conducted a significant part, actually the whole of my research work in collaboration with IUCAA. And after that, I formally joined IUCAA as a postdoctoral fellow and was working on the hardware and alignment of SOOT, which is a payload on the Aditya L1 spacecraft that we are all aware of. Finally, 2 years back, I have joined TCS Research in the Embedded Devices and Intelligent Systems group in TCS Research. So from where did I start and from where did I go up where I have come today? So when I joined CESI, IISER Kolkata, and I finished my coursework, I moved to IUCAA to start my work. My work was basically twofold. So one thing was the multi-wavelength observations of solar data that is already existing from space-based applications, space-based telescopes. And the other thing, and from there I was trying to understand that what is the data that is already existing and where are the gaps that a new instrument can cater to if it is launched. So it helped me to understand the technical requirements once SOOT was being discussed and we started working on SOOT. And I translated the scientific requirements that SOOT was intended to cater to the technical requirements, and then we started the designing end-to-end modeling of the instrument. I did some work on the alignment space qualification calibration during my postdoctoral tenure. I was also working on the designing and onboard implementation of various scientific and calibration modes, joint operations, the onboard safety logic conditions, and what are the things that we have to do, the data generation schemes, and even the failure of the payload. So what are the factors that could lead to the failure of the payload and how we can circumvent that. So once I was doing all these things, it led me to an understanding of what all exists and what is new and how to bring it to reality. So that is the difference that was part of my PhD and postdoctoral work. So when I joined TCS, I was given a plan that if you want to, in the scenario that you are given an opportunity to design a remote sensing Earth observation satellite, then what are the things that you want? So I started working on planning the mission objectives which have not been catered to, which have not been observed yet, or what better we can do for the existing things. Then I started working on marking the technical requirements for the same, and then the designing and modeling. So currently what I'm doing is I am trying to make a lab demonstration of the designs that I've done. In due course of my work, I've realized that there are existing techniques already for remote sensing satellites, right? So there are still scopes for improving whatever is existing, both hardware-wise and software-wise. And here I worked in detail for proposing some ultra-lightweight mirror designs. You can of course understand that this is not exclusive to remote sensing. Any space telescope, any mission team which is planning a space telescope and wants to decrease the mass and the cost for launching, they can utilize those ultra-lightweight mirror designs. So that I am right now trying to make a lab demonstration of that. Also, hardware and software come hand in hand. So once I designed some of these ultra-lightweight mirrors, I had to understand what is the post-processing for such mirrors for better reconstruction and denoising. So this is not a technical talk for me to give, but I would like to say that these ultra-lightweight mirrors that we have designed, simulated till now, they are actually optically sparse aperture mirrors, and they have non-uniform sized subapertures. So depending on the sizes of these subapertures, there are unique combinations of these size apertures. So if you have certain sizes and they are located at certain positions, then the resultant point spread function, which basically says how the instrument is going to see an image, that point spread function can have significant side lobe suppression. Side lobe suppression is very important because that leads to high contrast imaging even for the satellite. You are not doing any post-processing or anything, but there is high contrast image that is observed, and at the same time it leads to less of blurring. So whatever area we are losing because we are losing capturing area because we are creating an optically sparse aperture mirror, but then it is compensated by the suppression of the side lobes, which leads to high contrast images. At the same time, the location of these mirrors and the sizes, that combination is very important if we have noisy systems, which is mostly the case for all real observation telescopes. So if you go for these noisy systems, the designs that we have, so they are such that we try to concentrate the maximum of the spatial frequencies near the DC. So we try to avoid the high frequency components, because if you go by the traditional noise removal techniques that are used, then you are actually going to cut off the high frequency components. So, and that will in turn lead to loss of edge information. So you can see this image here, we have aircrafts here. Just imagine a system where you have been trying to remove the noise and you have removed the information about the edges of the aircraft. So there is nothing you can see actually. So that kind of thing is also important to understand, that depending on the type of noise and how much noise is present, there should be a smart pipeline, post-processing pipeline, which will identify the optimized technique, optimized reconstruction algorithm, as well as the denoising algorithm. So you can very well understand that this I'm talking from this remote sensing kind of perspective, but it is true for any astronomical telescope or any telescope which is going to cater to security, surveillance, even assessment of natural resources, like that. So yeah, so that much for my work that I have been doing. So I already mentioned that I'm working on this, so TCS research is already working on this. Apart from that, TCS research is involved in a lot of other sectors, like they are doing biomedical sensing, they are doing a lot of robotics for elderly care, for high precision surgeries where robotic arms are required to do high precision work. They are also doing a lot of machine and material and infrastructure inspection. A lot of these objectives, they come from, of course, a business oriented perspective, because you know we need money to sustain industry as well as to fund our research. So, so TCS is already involved in a lot of these things, and if you go here, you can see that there are some certain verticals that they are catering to. So if you go for sensing, then they are working on sensing, multimodal sensing, fusion of that data all the way from visible to microwaves, even plasmonics, nanotechnology, and also quantum sensing. They are also trying to infuse the existing amount of data with AI and vice versa, using AI to generate better data. They have a very dedicated group to work on communications, sustainable communications, low power efficient communication systems, where they are trying to make antennas and broadband devices. They do some edge and neuromorphic computing, which is basically, they are trying to develop systems which behave as if mimicking our human brain. So neuromorphic computing means that as if our neurons in our brain, they work, they are trying to make systems which are going to replicate that kind of a behavior. They also have some visual computing, and a significant amount of work goes to robotics as well. That includes development of hardware, like I said, for high precision activities, for surgeries kind of thing. And it also includes system automation, like if you have satellites which are in a constellation in space, then they need very well handshaking, like handshaking not in the terms of physical handshaking, but transfer of information and responsibilities from one satellite to another, or docking of satellites or any parts. So we are all working on all these things, like my teams, they work on all these things, and they have a lot of applications in various sectors, which include machine and material and infrastructure monitoring. They include human sensing, healthcare, elderly care, and biomedical. Then there is earth sensing, which is, of course, a part of the remote sensing thing. They are working for robotics, as I've already mentioned, and also artificial intelligence and visual computing. So what are the opportunities that TCS research is presenting to people who come from my background? So of course, we know that TCS works in data domain, that is for sure. And there is a trend that you infuse everything with ML and AI these days. So that is one thing that is there. There are opportunities for modeling experts, people like me who have done some modeling of instruments. In the past, they can use their capabilities, their skills in doing something here. And also even propagation of electromagnetic waves in human tissues. So here the attempt is that we are trying to use some terahertz waves to minimize the use of X-rays that we are exposed to regularly. Whenever we go to some doctor, we are asked to do X-rays. So you can understand that the propagation of electromagnetic waves is same, whether it is in astronomy or it is in some other biomedical sector. The only thing that changes are the boundary conditions, the dimensions of the objects that you are dealing with, the wavelength. So, and the medium that you're working with, the dielectric. So that kind of propagation of electromagnetic waves they are trying to do so as to facilitate biomedical imaging. They are trying to develop communication systems in terahertz region, in antenna broadband systems. Robotic systems I have already mentioned, and also the hand system automation. They have a very good vision, and they're trying to establish systems and technology solutions required to electro-optical, infrared, microwaves, plasmonics, nano and quantum sensing. Of course, the technologies that we have dealt with, the kind of image processing that we have done, the kind of images that we have seen during our PhD times, those all lead to they all form the platform, the basis. And these technology solutions, they can be applied. They have to be again modified depending on the scientific requirement now, but you can again bring it back. So knowledge is intertransferable. And as, many of you know that late Dr. Abdul Kalam had said that science and technology are two wings. So it is the same thing. So if you do something in science, you can transfer it to technology and take the knowledge back. So it's a complete circle. So right now TCS is doing that kind of an effort to put in research and also, of course, generate some revenue, because that is reality. So anybody who joins TCS research like me, I have joined as a scientist who can work on in any of the domains that I have discussed here, and even astronomy related projects. Many of you know that TCS had a role to play for SCA, or this international thermonuclear experimental reactor. There was something by the government of India, most likely it is government of India, I don't know who are the stakeholders. So many scientists were working with ITER, and we have TCS has a generous amount of PhD scholarships rolled out every year, about 20 plus every year. They prefer having some research program which is aligned to their interest, but there is no hard and fast rule about it. Like I myself have evaluated a project last year, a PhD proposal last year, which was about Indian pulsar timing array. So they are open to it. They have internships also from different IITs, IISERs, IIST, NITs, and I have myself mentored a person from IIST who is now a colleague with me. So TCS is basically offering a wide variety of opportunities in research, and there are scopes where the knowledge, the skill set that we come from during our PhD times can be applied, and we can return our knowledge back to the scientific community also. Thank you for your attention.
Thank you, Varthana. I would request Mr. Ramakrishna to set up his presentation. So again, as you see, these are only representative examples we could showcase today where this kind of exchange and avenues do exist. It's not a comprehensive list. So we'll have Varthana back on stage. So on the panel part, we will discuss with the students how these opportunities can be approached and how we can disseminate this information also across. Yeah, all yours, Mr. Ramakrishna.
Hello. Yeah. Thank you, ASI, for giving me this opportunity. I'm Ramakrishna. I come from photonics background, and I'm working in Optics and Allied Engineering Private Limited, the company based in Bangalore. So we primarily work on optical systems for astronomy, space, and defense applications. So we are one among very few industries who work in this field. So I'll take you through our journey where we started and how we are contributing to this industry. So we started as a small industry of optical glass suppliers in 1985. So then onwards we have grown step by step. So you can see that we have added many ultra precision optical machinery and then testing machinery. And then we have added clean room facilities for thin film coatings and then electro-optics assembly facilities. So we have grown step by step, and then now we have reached to a stage where we can contribute significantly to the the growing space and defense and astronomy industry. So we are an ISO 9001 and 2015 company. We have received multiple awards for contributing to the research for the industry. So majorly we work in this, we have strength in 4 segments. So we have a nano machining center where we do the infrared optics, where now the infrared optics and metal mirrors are becoming popular in the telescopes. And then electro-optical systems, we have a complete in-house facility where we have required softwares and then machinery and then optics fabrication facility. And then we also have optomechanical manufacturing facility, very large size optomechanical manufacturing facility. And then we also do a lot of polymer optics, wherein we want to replace most of the the bulky optics with the polymer optics. We have started using geonics and opal like kind of a materials where we can replace most of the optical materials with the plastic optics, where you can have advantage of weight reduction. So this is very unique facility that we have in the country. So this is a optics fabrication facility wherein you can manufacture high precision lenses and then mirrors. So we have a capability to manufacture the lenses as small as 5 millimeters to the mirrors as large as 2 meters. So that's our capability. And then we have a single point diamond turning facility wherein you can do the non-spherical optics, be it metal mirrors or plastic optics. So nowadays the trend is becoming like where you can do a prototyping of the metal mirrors very quickly using these machines, and then they are very accurate. And then the core of this, any of the space-based telescope or any kind of optics, it's a thin film coating where you can enhance the reflection of the surface to up to 99%. Or if you want to have an anti-reflection coating.
Space objects, it's satellites and debris. Sorry. Right. This can be done by 2 kind of technologies.
So where you can have an anti-reflection coating wherein you can enhance the transmission up to 99% and above. So we have a diamond-like carbon coating facility also, wherein you can increase the hardness of the coating of the optics. Infrared optics is very sensitive to the any kind of rubbing. So we have a complete facility for doing thin film coatings. And then these are the high precision glass machining centers wherein you can have the ultrasonic glass machining centers wherein you can do the glass optics with stress-free machining. So when you do any optics with any diamond tools, so you will develop the stresses. But wherein ultrasonic precision glass machining center, where you can do any kind of a 3D structure of a glass without having any stresses. And then 5-axis CNC machine is used for lightweighting optics. So we do a lot of lightweighting optics wherein you can reduce up to 30 to 40% of the weight of the optics by lightweighting. So we can do up to 2 meter size optics using this machine. So these are the metrology machines. You can these are the machines that are used for qualifying the optics. So these are the spectrophotometers where you can measure the transmission and reflection of the optics, and gygo-interferometers are used for, measuring the form errors of the optics. So this is our product portfolio wherein we use the precision optics, IR optics, thin film coatings, and glass machine parts and electro-optic systems. I'll show you some of the projects that we have executed recently for the astronomy and then space industry. These are some of the application areas. So we are the official partners for TMT in India for glass machining and then sensor block manufacturing. So as you are all aware that the TMT primary is a 492 segmented mirror, and then so about 80 plus mirrors is part of TMT India, wherein we have taken up the fabrication of the segmented mirrors. The work involved is polishing of the primary mirror, which is about 1.2, and then once the polishing is done, we need to do a hexa cut without adding any stresses to the mirror. And then there is a sensor block, which is, there are about 12 sensor blocks for each primary mirror segment, so which are used for translation and tip and tilt, the feedback adjustment. So this is the work that is ongoing projects with us, and then the sensor block also requires a thin film coating, wherein we need to do a gold coating very uniformly across all the dimensions of the the block. So this facility is completely established for executing this project in the country. This is a very unique facility what we have. And we also supported many of the astronomy related project. For example, some corrector lenses we supplied to ARIS, which are used in the spectrographs for image correction. And then there are non-deviating prisms, which are a combination of two different materials prisms for zero dispersion of zero deviation of dispersion of light that is being used. And then we have also supplied some of the lenses for IAAP, which are used for star tracking lenses, which are high-end, high accuracy lenses. So these are some of the works that we have contributed to the astronomy. And some of the other applications that we have already working on is Schlieren systems for hypersonic wind tunnel. So these systems are used for testing of the structural strength of the high-speed high-speed jets. So these are installed. This is installed at DRDL Hyderabad. So the other systems that we have already working on is for high power laser beam director assemblies. So these are specific assemblies wherein you have a high precision, high energy laser light, which is used for destroying the drones and then other defense applications. So this requires a high-end coating wherein you have to build optics and coatings to withstand the high power laser beams. So some of the other applications that we are building system, electro-optic system, is for in the LiDAR field. So this is a aerosol LiDAR which is used for cloud monitoring and atmospheric monitoring. The complete optical assembly, optics manufacturing, coatings, and then all the assemblies, testing, everything is done in-house. And these two are the very recent works that we have done for the defense, wherein these systems are very compact LiDARs which are used for the measurement of the direct detection and measurement of the gases like CO2, methane in the atmosphere, which are again these systems are used for defense applications. So again, this is a recent system that we have built for beam director optics, again adaptive optics system, wherein the laser light which is directed towards atmosphere, and feedback is collected, and then it is again corrected, and then it is the beam shape is maintained using this system, which is very unique system, which is first of its kind in the country. So these are some other application wherein you have a wide field infrared imaging application. So see, all these applications requires lot of optics engineering and then optics, precision optics manufacturing. We are well versed with that. So a lot of infrared optics is also built using the facility that we have. So also we are working on missile seekers for the defense applications. So these are one among the many applications that we are building electro-optic systems for. These are again the optics which we are building for a free space communication. We have collaborated with Google. So these are used in the the terrains where you have very difficulty in laying down the optical fiber cables. So these are all the systems that we are building in collaborations with the labs like ARIES and then astrophysics, TMT, and then other areas. So we expect the people who are interested in building this optical industry, optical systems, we encourage them a lot, and then we offer a lot of PhDs and then a lot of internship. So I welcome any of you interested. You can reach out to us, and then we can work together to build our nation. Thank you.
Thank you very much, Mr. Ramakrishna. So I would now invite the other panelists to come on dais, please. You please also take a seat. First, Dr. Ajit, our own Ajit, to help us to run the panel. Also request Dr. Satyanarayana from informatics, so how informatics can also help us. Please take your seat. R.T. Prabhu. He was a JAP student, same batch as me and Ishwar, Annapurni. Probably he should have been called for the group photograph yesterday, but he was not aware. Please, so we'll have a brief introduction of the other panelists as well. Tanveer, please come on stage. Abharthana, please take your position. And I think now Mr. Raghu is also in. Yeah, you're here. Okay, thank you. Yeah, let's start the panel. Yeah. So we'll have some specific, and then we'll hear the views of the panelists, and then we will open it for the audience to have questions or comments related to that. So first, let's have Prabhu, your journey so far.
You want me to take the questions, or you want me to tell you about my journey? It's going to be a long one. I'm an old man, and so you see the CV there is filled up, but I've tried making it very simple and even to remind myself what was I doing then. So can I just stand up because I want to see the slide? I just want to stand up. This is a brief introduction. I did start my journey in astrophysics, and I love astrophysics. I still love astrophysics. But then there was this urge to do something with the toolkits that you had learned during your PhD. So PhD is just problem solving, it's a training in problem solving. So please treat it like that. And whatever toolkit you learn, whatever techniques you learn, you have to learn how to relate it to any other area. And there's a very interesting quote by Norbert Wiener that the most productive areas in science are the ones which are at the boundaries of two different fields. Okay, so it's very, very important to understand that science and engineering, technology is a very complex enterprise. So I have a lot of people who are extremely specialized in the areas of their choice. But at the same time, my advice to my youngsters is you should be able to exploit a wider space of opportunities if you have trained yourself to relate the techniques that you know, the knowledge that you know, to any other area. So my journey started from astrophysics, where I was trying to apply concepts in fluid mechanics, fluid turbulence. So I don't know whether I wrote it here, not here, but that was about how structures are formed in a turbulent medium. Now, had I written down on my CV that I tried understanding the rotation curves of some galaxy, nobody would have, understood what I really learned and did. So I sold myself. Yes, marketing is not a dirty word. I sold myself as a fluid dynamics guy. And I tried finding openings for myself, okay? After that, I moved on to, I did an opportunity in Singapore. After my thesis, I went to Singapore in the Nanyang Technological University, where my job was to use the same numerical techniques that I learned while doing my thesis, and branch out into numerical methods, so modeling. So the topic there was to cool computers. Computers are hot. You want to cool them, they're going to get hotter. Sometimes the heat that is generated per square centimeter per second will vie with that on the surface of a rocket. So I was very excited with that. So the key point is keep your antennas open and read about what's going on around you. What are the hot areas? Relate, learn how to relate. I did my job and I developed a code. I was a coder, learned my coding while I was doing my thesis. And then I moved on to, so that was micro channel cooling, bottommost thing in my CV. Up very fast. Since Dipankar didn't give me 10 minutes, I think I'm going to steal something here. So worked on compliant flow.
That is interrupting with the battery.
Okay. Is this clear? Is this clear? Hello? Yeah. Then I moved on. See, the common theme in my life after that for some years was fluid dynamics. And that had a common, I had a small berth in mechanical engineering where I could talk about a little bit of what I knew about fluid turbulence and fluid flows. I worked on compliant flows because I was very passionate about trying to apply what I learned to some engineering problem. And the closest engineering problem was drag reduction. And how did I learn about drag reduction? That was a book fair in Shivaji Nagar where I bumped into one Springer Verlag edition, which was saying that, fluid mechanics and drag reduction. And I learned the basics of drag reduction and kept it in my pocket, kept it in my mind. And I was dreaming about it and saying, the techniques I know, I should be able to apply it in drag reduction. And 1% reduction of the drag on your airplane wings or on your cars is going to save you billions of dollars in fuel. So that was a motivation to work in that area, or at least try to work in that area. Not that you're going to solve the problem overnight. It was just like, you are hopefully on the right track, and sometimes it's a hot track, and you'll be in demand soon, right? So I worked on compliant flows, drag reduction. I got an opportunity to go to Rice University to do a postdoctoral work. The same thing that, which was the theme, drag reduction. I worked on one aspect of taking a complex flow and reducing it to very simple eigenfunctions, okay? So that's called proper orthogonal decomposition. Now, this proper orthogonal decomposition is nothing but, it's being used everywhere. It'll be used in data science. It'll be used everywhere else. I'm going to cut down my journey short. I became a research assistant prof in University of Vermont, taught, wrote grants, supervised students, but then something was itching. I still wanted to find my way to industry. I was not in industry yet. I found my opening when IBM was opening its Semiconductor Research and Development Center in India in 2007. So I wound up my American dream, and I came back to India to work in industry, and I was the second guy to join the Semiconductor Research Division in India. And we got completely trained. So this is one more point for everyone who wants to make a transition. Don't get scared. There will always be room to train you. There will always be room to train yourself. You don't really walk into a job interview or something saying, I can do everything of your problem. No. I can solve your problem. No. You go there with the right attitude. You go there with the right toolkit, and you just convince them that you have the drive, and you also have the capability to start solving the problems. You're not giving them an answer overnight, okay? So I found my break in semiconductor research, partly because I was doing I did my electronics I did my master's with electronics, and I hated electronics at that time, but I started loving electronics when I got this job. Okay, to cut a long story short, blah, 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 I learned, I went back and forth between industry and academia. Right now, where I stand today, I head a small team of bright PhD engineers from the IITs, and we solve some of the very important problems that happen when all of you take your cell phone and rub it against your shirt. So we solve problems of electrostatic discharge. It might sound like a big word, but it happens every day. And so that keeps me driving every day. How do you come up with better ways to handle the unwanted electrostatic discharge that can really fry up your phones and other gadgets? So we develop models for high currents and high voltages of ESD events. And that's where I am. I'm working with Global Foundry, and I'll be glad to interact with you more. I hope I made myself clear, and I'll invite any questions. Thank you.
I've been following Prabhu from my BSc days, so I knew that he needs 1 hour. So we'll have a very brief introduction for a couple of minutes for the other panelist, Mr. Satyanarayan. Can we have? So we don't need to actually, I think the others can read the detailed profile, but if you could just kindly, introduce yourself, please.
Good afternoon, everybody. I'm happy to see a lot of young faces here. Looks like India's successful moon landing has created a lot of interest and excitement for people to get into your domain of astronomy and astrophysics to explore spaces more and more all around. Now, I come from information industry. It's some way caught between information and technology. When I say information industry, we are significantly in what we call scholarly communication. That's very much part of all of you. I would say that we are more like partners in this, you are all partners in this industry, because the whole, it's all about managing information from its point of creation to the point of delivery and through multiple media. In fact, when I got into this business as an entrepreneur almost 40 years ago, we started with a kind of an online. There was most of you may not even know that there existed something called online before internet. We started with that kind of online in accessing content, information. It was a small world, but internet dramatically expanded the scope of information industry business all around the world. And what you see as a result of it is something like Google and whatnot. Now coming to what you all people do, and that's where we do quite a bit of work in scholarly communication. We publish journals, we produce databases, largely for entire science and technology spectrum, where your domain is one part of it. So, and this is an area where certainly with a lot of changes in technology happening, a lot more opportunity for people in the scholarly publishing domain. It's not just publishing, the whole quality of publishing. And your society publishes one very important journal in collaboration with Indian Academy of Science. In fact, it's one of the best journals among the 100 plus journals in the astrophysics. You rank around 20th place. And you also used to publish bulletin. I don't know why you stopped it. It was ranked among the top 5 among the 100 plus astrophysics journals. That's the space where we are, which certainly provides a lot of opportunities as the quality of Indian research and Indian publishing improves. In fact, the problem of Indian research and publishing, which employs, for information management, information handling, less number of people, whereas the rest of the world employs a lot of people, is largely somewhat quality related issues. With a lot improvement in quality, I guess, you will have a lot more opportunity. That's where you can deploy a lot of technology available. Let me stop at this point.
Yeah.
And we
Yeah,
can take
thank you,
questions.
thank you. Yeah, may I request just Mr. Raghu to introduce yourself and have his profile. So the idea is, as I said, the today's theme is career opportunities and exchange of programs and so on. He's from the data sciences.
Can you hear me?
Yes.
Yeah. My name is Raghu. I am the CEO of AI and Robotics Technology Park, which is a non-profit organization actually based a couple of 100 meters from here. We broadly do three things. We build startups. We build platforms that enable innovations by multiple innovators. And we also do skilling. My own background, definitely not astronomy, not even AI or data science. I have somehow made a career between two sets of highly impactful people, folks who actually work on the ground, implementers, as well as the innovators. And last few years have been especially focused on bringing the richness of data science and AI innovations to real world challenges, such as, lots of folks got into computational modeling during COVID. Right? I'm sure lots of folks do that here, but you probably don't deal with epidemiology. Similarly, we work in areas such as health, climate, also language AI. So with that, back to you.
Thank you, the panelists. We also have two other members actually who have been also helping us organizing this meeting. From Kalam Labs, Mr. Shashakt, and from Yagnikul, Mr. Yatish. I will take them on board, in a while. So let's just start some questions about, again, the career opportunities in the industry for young astronomers. And I think we were also discussing preliminary with some of the panelists that it's how young astronomers can present themselves in the industry. Because often, as I think Prabhu pointed this out, that if we would have gone to an industry and showed my research results, I don't think industry will be very impressed. So what kind of way we could present ourselves into the industry? What is the expectations from the industry? So let me hear from Abhardhana first. How did you present yourself in TCS research?
So when I presented myself, the first thing I was asked, actually it was even before I gave my technical presentation, I was given a question, like if you are given some funding, what would you design for a satellite system for? It could be any field. They had given me complete liberty. So I tried to implement, like I was talking in my presentation. So whatever I was doing during my PhD, I had known that what are the gaps that are existing. So that kind of analytic mindset was there, that what are the existing things, what are the gaps, and how to cater to that gaps. So that is the same thing that I had applied when I was writing that proposal. It was just a interview-related proposal that time. So that was one very good thing, that like it is very necessary that whatever you have done, you have learned, you should know another application of that same thing. It is not that you will know that whatever you know, it's a very good thing, but not always you will find an opportunity to exactly implement it. You should know how and where to modify it, how the same knowledge can have different applications. So that was what I was given. I was from astronomical instrumentation, but I was given, I went to remote sensing because that was one of the sectors which is very much important for people on Earth, and given the current global scenario, there are requirements that we need to look into. So that kind of things, how to, like, just as I was saying again in the presentation, propagation of electromagnetic waves is same. It only depends on what medium you are dealing with, what is the dimension of the object you are dealing with, what are the boundary conditions that are set. So you will have to know how to switch between those things and how to modify those things. And the basic knowledge, the basic application is same. Like when I was doing my PhD, of course, like other PhD students, all PhD students agree that there is a basic drive that, okay, I will write papers. So most of the domains of astronomy, they have some routines, some packages. Like in solar physics also, we have packages. So there is a way that you just implement those and you get your results and you publish the papers. But when I was doing my PhD, Durgesh, who is walking down the stairs, he was very serious that I understand why and which routines I am using. So there was this eye spectrometer, so there was this orbital variation which causes some changes in wavelength. So that thing he ensured that I understand why that is happening. So now I know that when there is a satellite in an orbit, there is perturbation and there could be implications in the data as well. So that is where the things are that you should know applications, you should know the why and how you are doing things. So that is very important to make a shift if you want to do it.
Okay, so let's now open this to the audience, and I would encourage youngsters or even seniors to pose questions to the panelists on this aspect to start with about the career opportunities in the industry. And these are representative examples of the industry, so let us try to focus on these areas for the moment today. Yeah.
Hi. So a lot of times we have, especially undergraduate students, who ask us if there are, sometimes even graduate students who ask us if there are specific certifications, because there's this proliferation of online certifications that you can get and so on. And if any of those would actually boost their chances of successfully transitioning from academia to industry. Part of it you have all already answered, that it's a question of how you project yourself and show your core skills. But what are the other metrics that industry would care for people who are trying to switch from a core academic area into industry?
Okay, so Optica, Mr. Ramakrishna, yeah, wants to respond first? Keep the things on, yeah.
Hello. Hello. Yeah. So as part of my job role, I conduct a lot of interviews day in, day out. So to answer your question, so other than your core area, so when you start to work in industry, after a certain period of time, it's all about your leadership skills and then program management skills. So, nowadays the projects that we are dealing with in industry is a large scale project, and you need to work with the wide varieties of team members from different backgrounds. So what we always look for the different perspective in a candidate is a leadership skill. So I would say anything related to the program management and leadership skills will be definitely helpful for your career improvement or getting an opportunities in these areas.
Yeah, Mr. Raghu, you're in the data sciences, and I think a lot of our young students are fit for your domain. Would you like to say something?
Sure. See, we solve very on-the-ground problems. You are in the heavens, right? The kinds of problems we solve are, for example, on the commercial side, startups, right? We have lots of autonomous systems work that happens across our startups. They are drone startups. Right? And all these folks are looking for people who also have lots of background in instrumentation and such. So one, I can see lots of relevance. In terms of certifications, etc., I think more than any certifications, practical experience matters, right? And you don't need to have to do 6 months of internship somewhere. It might just be 2 months of engaging, right? As, maybe during the semester, part-time even. And it makes a huge difference in how you engage with the problem, because ultimately, the idea is to problem solve. And there are trade-offs involved between what you do, let's say, on the AI or data science side, and what the challenge is, and what the skill sets are. To take the example of health, if you are going to do early stage screening of oral cancer, what you're dealing with is skill sets of an ASHA worker or A&M being able to take good pictures. If you are dealing with a lab scientist, maybe that lab scientist will do it perfectly. So how do you get decent enough predictions based on imperfect data? Right? These are the sort of things that we deal with. Now we are also bringing lots of climate data into all of this, and I'm guessing folks here know this. For example, we have probably one of the largest systems in the world where advanced predictions of dengue outbreaks are being given down to a block level. This is across Karnataka, Pune, Pimpri, Chinchwada. We work with PKC, for example, to do this in Pune. So I just thought maybe give a flavor of where data science comes in for on the world, on the ground examples. And we do this both in a for-profit mode with startups and in a non-profit mode with global organizations such as WHO, etc.
Yeah, more questions from the audience? Yeah, Durgesh?
Yeah, so my name is Durgesh Tripathi. I'm a professor at Ayuka, Pune. I have a question on, like, could we start thinking in a way that with industries where there is direct application of science and basic sciences and then applied sciences together, could we think of putting together joint PhD programs where the students could share time at institutes, academic institutes, and also at industry, whereby there could be much more closer ties? And if we have that, what is the way to approach it?
Yeah, we have started discussing, and I had this point anyway. Yeah, Digantara is one which has already started, and I hear TCS also has these opportunities. But these opportunities are not actually available to the community in the sense of announcements or advertisement. So I would have probably done this exercise at the end. So ASI could actually act as a, as a forum where as we advertise for the jobs from other academic institutions, we should also advertise for the jobs which is available in the industry. So please, take note of that. Whenever there is such opportunities exist, please let us know, and we will circulate that information among the astronomers. Yeah, please respond to that, Tanvir.
Yeah, so I think the simple answer is yes, at least from my side, from the Gantara side. I think I ended my presentation on that note that we are open for funded PhD programs or joint PhD programs wherein although the science part is done by you, the problem statement definition will be done by us. So if that is something any of the institutes are interested, I'm very excited to start working in that area. But with industry, what I can say is, especially startups, right? Basic or fundamental research is something that will not be that is not a very good fit for us. It has to be application oriented. So it will be problem statement driven rather than exploratory driven. So as long as the willingness to work on clearly defined problem statement is there, I think we are game on that.
So if I may,
Sure.
is there a possibility that we get together and discuss the problem statement itself, which is both basic sciences and applied sciences together? Yeah. Right. If that's opportunity is there, that will be
Let's catch up
fantastic.
after the session.
Yeah, questions, yeah, there. Vagish in the middle.
Yeah, so the following of the previous question, that already many faculty and scientists have realized that there is a need probably that PhD students need to be trained parallelly in the institute and also in the industry so that they can properly know what is happening and they can properly fit into that system. But my question is like that, is there any survey, like are aware, like my question is to Tanvir, that like in space awareness, where do you see a pattern that most of the space like trend, like PhD students or graduates, when they reach to you or your company similar to that, they are very fit, or you find that they need to be further training, so that we can understand that when we are training the students, what need we actually like develop in them, and so that they can use that. So on that, what is your comment?
So I think one reality that both the industry and academia has to accept is there will never be a perfect fit, right? So if I list out my requirements, 10 qualities will never be like, all 10 is ticked. I mean, I have never had someone who ticked all the check boxes. So that is something I think everyone here from the industry background understands. So overall, what we are while during our recruitment process, right, what we are trying to understand is we have those series of, recruitment rounds or conversations. The whole goal is based on the problem statements that are given, based on the conversations that we have, the ability for the student to perform in that particular small interaction, we have to take a bet on that particular candidate, that will he be able to solve a larger problem. So in very simple words, it's like what we are trying to do with that hiring process is if he satisfies certain condition in the hiring process, then we say he's capable of building this particular project that might last for a year or two. So that is how overall the hiring process would go. Everyone has their own way of implementing it, but I think it's a simple if condition that we have to answer. Like in my case, I have to in one way or another pitch this particular candidate to my board. I have to defend this particular candidate, not like in a formal thesis definition, but I'm accountable for that, right? I'm accountable for that. Coming to your point on the learning, does a learning curve exist or not? Yes, it does exist. And when it comes to when we are looking for these candidates, we look at certain areas that we start looking. Okay, why do we need this particular candidate? The big problem statement. From there, we trickle it down to something very small, and focus our recruitment process only on those. It could be usually a factor of three things. One is core competency. We try to find some core competency. This could be perhaps we are looking someone in background of image processing, or image processing of perhaps slightly going into high contrast images, not like for drone or something like that, something very specific. So we try to see if we can find those kind of specific people, and if they have anything related to that, we tend to advance them. After that, it's unlikely that they would have been working in the problem statements that we want them to work to. That is almost not the case. So the second is considering they know a particular tool. Let's say they are very good with Kalman filters, they are very good with optimal control theory and things like that. Do they have a mind open enough that they can apply the same tools in a different problem, right? Understanding the problem and things like that. And last one is the culture fit round. So this usually is more on the softer side, but I wouldn't say this is a primary criteria, the culture fit. But still, if there are certain red flags, we have decided few people at the culture fit round that will not move ahead with them. So that's how the recruitment process goes.
Okay, there's a question in the back from the youngsters. I would actually encourage questions from the younger people more. Please.
Yeah, so I kind of...
Oh, sorry. Prabhu, I wanted to just
I just wanted to add, you wanted to define a problem which is common to both industry and the research work, right? Internships are a very good window where, we can afford to have the candidate with a very good basic background, not necessarily 100% fit, but the candidate has the drive and the motivation and the teachability. He is a teachable candidate. So I have some tools with me. I want him to learn that. I have a problem that is very tricky. I don't have time to solve it. That is how we define our internship problems. Internship is like a birth for somebody to come and both learn what's going on in the company as well as contribute their might to the problem. They are seeing the company culture, and they're also getting a flavor of what problems there are. So I think the first step will be to look for such arrangements like internships. And internships, I'll tell you, it's as good as an interview, right? So it's as good as a job if you are doing well in the interview and the internship problem. Say I'm designing an LNA amplifier. Somebody who is working on instrumentation. Say, somebody, okay? So if he has very good basics, what I look for in an interview is how well does the candidate answer or explain what he already knows. He must have spent a lot of time working on some problem while doing his thesis itself. That's a very good thing. So the candidate's presentation skills are check, good. Next stage is how well can the candidate, how well can the candidate perform when he's given a small challenge? Does he have the openness to admit that he doesn't know anything in the first place? Openness is very important. Okay, so I'll just move on to the next question.
Yeah. Okay, let's have that question first.
This is a question related to the recruitment process that we are discussing right now. Sometimes the people in the recruitment team who are actually selecting your CV do not act, they come from different backgrounds, and they sometimes could not relate to the research experience that we have. Even though I try to portray or try to connect my research experience to the to have an industrial shift, I try to tell or sell myself with the kind of knowledge I have from my research experience. They could not, these people cannot sometimes relate to that CV, right? And we sometimes could not pass through the interview selection, and even in that stage. So, like, what does the team or the manager team can do or solve like this kind of gap from the the candidates to the recruitment team to the people who are going to interview you?
Okay, Mr. Raghu, please.
I just want to say simply this, right? I'll ask you a question first. How many companies do you apply to as an individual? Let's say in a single day. You can just say it out. How many resumes do you think I need to go through for a single position?
1,000.
Yeah, I wish thousands, but hundreds easily. So first, please, some empathy, right? So you have to make it easy for me, who does not know anything about astronomy, understand how you bring your transferable skills, right? 3 tips. 1, look up the company you are applying to, understand what transferable skills you need, and hence highlight those, right? Lower technical jargon if that's what you think will be useful. Number 2, get 2 friends through your LinkedIn who may be in those spaces, those sort of companies, to review your resume, right? Number 3, right? Get it to someone who will go through your resume, and whatever transferable skills you have that you think are relevant should be apparent in my first 10 seconds in the first 1/3 of your first page. Because guess what? There are many such deserving candidates, and I cannot spend 2 minutes.
And I think we were discussing earlier also the SOPs, how do you write SOPs? We have a tendency, we write a CV and we send the same CV to a number of places.
No, we do take the effort to try to change the CV as per the position we are applying to. But many times they try to get people who have experience in the industry itself, right? Like we do come in the back end. Like we are not. I mean, it's very difficult to transfer the field actually.
Aparna, you want to comment on that quickly? Yeah, short comment.
Well, I can't agree to it, but maybe different people have different experiences. My friends have also been having similar experiences, but that is what Dipankar was saying. SOP is the way through. So whatever transferable he was talking about, Raghu was talking about, you will have to bring it out, reflect it in the SOP. Your CV is generic, whatever degrees you have, whatever publications you have, that is going to be true everywhere. The SOP, 1/3, half a page or 1 page of your SOP should say the rest of the things. That has to be company specific and the position that you're applying for.
I'll just slightly add one point here.
Yeah,
So,
quickly, yeah.
A quick anecdote, I would like to tell you the first PhD candidate that I had. So his ideal career path was to become a professor in a college that I learned. Right. So from there, somehow I got in touch with him, and he's one of the first hires that I've made, and one of the brilliant asset in my team. So overall, when it comes to coming from the research to academia, I wouldn't say there is like one straight path, right? There is always that fit that has to be identified. But I think there are more amount of stories that we have that, very diverse kind of stories that this is happening. It may not be there to the extent that, that everyone would want, but they're definitely happening.
Okay, before I take the next question, I would actually request Ajit to just share. You want some point? Very quick, huh?
I can't let this go because I can feel your pain and I empathize with you, okay? So I would only advise 2 things. One is you should prepare a nice small PDF copy which you will circulate along with a brief 1-page CV. It may be 6 pages, it may be 5 pages, but you will make it so cute both with visuals and explanation, buzzwords, catchwords, that anyone who is keen, who flips even 1 page, gets glued to it. Believe me, I made 6 pages of my thesis work that I did everywhere. I mean, my problem. So do this. Document what you did in a little bit more detail than mentioning a name or the title of the project. And last but not the least, I was telling this to Dipankar, networking is not a dirty word. to me earlier, it was a dirty word. I said, I'll get a job by myself. I will put it on some portals, I'll apply 100 places. When you know certain people and you want to ask them for some advice, and they will get you the audience with somebody who is going to interview you or talk to you at length, that's your opportunity also. So networking is also an important concept, important thing, okay? I'll stop here.
Thank you, Prabhu. So before I take another question, I would request Ajit to share some of his experience, please, because this knowledge clusters, this is also a government effort. It's a perfect example of industry and academia partnership. So please, Ajit, share your some comments, please.
Brief, because I know people are waiting for lunch. And so the thing is that, first of all, there are about 650 young people attending this meeting. That number is much larger than the total faculty positions in the country right now. Okay, so which means that, and even if they increase at the rate of 20% per year, you're not going to get jobs. Right? So, but does it mean that you give up astronomy right now and walk away? It is not so. Because there are many exciting things to do afterwards, which is the flavor that we are trying to convey from here. And please bear that in mind, number one. Number two is that transfer learning is extremely important. And we all do it in AI, because you have trained your system on certain, on a training set. Okay, but now that means that your brain is working so that you can be trained much more easily in the second round. And that is incredibly important, because there's no point in you saying that they are not calling you for an interview. Because it is that you have such skills that very, very few people have in the country. Okay, you are just trained to work on very difficult things. And that transfer learning is definitely possible. Okay, then number three is that what has not been emphasized here is your skill sets, like data analytics. I never understood the word data analytics. But what does it mean, the phrase? And then I realized I've been doing it for 50 years. Right? And so we have real expertise in it, and that should not be discounted. Okay, because absolutely everybody needs it. Right? So if you put it all together, you find that there are opportunities. And the point is that if you want to enjoy doing astrophysics now, and you also want to compete for the small number of positions that will be there, you have to take a risk. And if you don't get those positions, are you going to go on downgrading yourself and remain there come what may, or you want to do something very exciting which is possible? And the last point I wish to make is that just like you are talking about internships from internships which will give you exposure, which will allow you to network, what happens abroad, and several people in India also have talked about it from time to time, is that people from the companies can get, people like you, senior people like you can take a few months off and come on a sabbatical to an institute. Okay, so that is also completely possible. And it should help very much to have this kind of a give and take. And without the give and take, astronomy is going to just keep going down. But you have much to offer.
Thank you very much, Ajit. One question from there, young lady.
I think I'll just build on what Ajit has been saying, and I think a few others as well, about internships. And I think it's also a difficult choice for PhDs to be making when they're supposed to be for their family or otherwise transitioning into a stable job, or like at least a paid job. And I think internships have been mentioned quite a few times as this bridging gap, because even the industries do need the PhDs with that skill set. It's just about finding that right bridge, which does work. And I'll make it very simple for the sake of time, which is just a yes or no question. Are the companies actually offering paid internships to find that bridge?
Yeah, we will advertise that in the ASI webpage.
Oh, yeah. So, I
yes is the answer.
Right, but my neighbor here from ASI is saying yes, and even I would say yes. Till now at Digantara we have a culture that we don't hire for free. That's a culture that Digantara follows. I wouldn't say that everyone offers paid internship. There are a good amount of people who do unpaid internships. But at Digantara, it's only paid for us. The reason for us is once in a company, once we put any amount, right, any small considerable amount there, it brings a very different kind of accountability. Right? If I hire a free intern, my CEO, he doesn't care what I do with him. Right? But if I pay anything for him, he asks me, what are you doing with that particular guy? So that is the reason why we do it. So all our internships have been paid. And it's not a dedicated internship program, I would say. It's a transitioning phase for a full-time employment. So that means usually like one of the last week I closed an internship. I like that one particular candidate. He's now in 8th semester of bachelor's. So I'm okay to hire him immediately on full time, but because he's a student, I'm giving him an internship for the last semester. So this is how it is, at least on our side. Feel free to add.
Okay, so very briefly, actually, as I mentioned, there are two other, individuals who are also here. Agnikul, will you please briefly, because they have been around and they have also some opportunities. Can you just say very briefly about your work?
Hello, everyone. Thank you for inviting me, sir, first of all. So, as you know, satellites, due to advancement in technology and miniaturization of electronics, what has happened is, over the years, the size of the satellites have come down. So, what a 1,000 kg satellite could do a decade ago can be the same done by a cluster of 100 kg satellites today. So, as you can see, more satellites are being launched in space, and because of that, there has been rise of launch providers. So, what we do is, Agnikul is a private launch vehicle startup incubated in IIT Madras, and the objective, what we do is launch anywhere, anytime, affordably. So, what we do is, we launch anywhere from 30 to 300 kg payloads into the orbit of up to 700 kilometers low Earth orbit. And our team consists of 240 employees, and we are advised under the under 45 scientists from ISRO. So when any satellite manufacturer come to us, we only ask 3 questions. What are the dimensions of your payload? What is the weight of it? And when do you want to launch? Now, when we say when do you want to launch, what we aim is to launch it within a time frame of 3 weeks. How we do that is, first, we are the first globally, we are the first one to have a single piece 3D printed rocket engine, which can be done in 72 hours. A traditional rocket engine would take around 6 to 8 months to assemble thousands of components together. We can do it in 72 hours. Second is, we are the first in India to have our own private launch pad. So that gives us the freedom to launch at our convenience. So that enables us to launch within a 2-week time frame. So these things enable us to cater the requirements. So
Thank you very much. So Kalam Labs, Shashank, they are doing some balloon experiments, interesting. Yeah, very briefly, yeah.
Hello everyone. So this is Sashak, Faraz, Prateek. We are from Kalam Labs. Kalam Labs is India's kids space research organization. So we primarily organize particular projects in which kids create those projects, and they are around the space exploration. So for example, recently we collaborated with TIFAR, Hyderabad Balloon Facility, to launch our payload at 36 kilometers altitude into space, which was basically a Tiranga, which we hoisted on the Republic Day. So our primary why behind this thing is that kids, if they start working from a very early age in this direction, they start thinking about it, they are going to become leaders in this going down like 10 years to 15 years down the line. And primarily because we are a space research organization, so like astronomers are particularly important for us. And what we look for is if they can solve practical problems. For example, if someone can create multiple types of telescopes and they basically know what the particular fundamentals are, that is really the core thing that we look for. And we try to teach kids about that, and then kids make those things, which we then launch as space projects. Yeah, thank you.
Thank you very much, Ashak. So as you see today, we are just giving a very subset of, representative examples where, new startups, established companies are changing their mode of operation. So one thing is, I think the take home is the active internship program and joint programs. It could be even PhD. I don't know, Arnavda is probably not around. JAP program may think about coursework project in industry. So I think we have to change our mindset as well. So I think that is what, from ASI's front, we were trying to get a forum where we could start, talking to each other. And we hope in future we'll have a much better exchange platform with a longer thing. So I would thank all the panelists for coming over. Please stay back with us for lunch, and would also request, because I don't want to get into too much in the lunch time, but if other want to interact with them, have further questions and further details, I would request you to stay back. Okay, so there is one more question. I think he's raising hand for quite some time. Okay.
Thank you for the time. It's a question, more of a thought I had. So talking about give and take, one of the things that discourages me from joining an industry is although I have transferable skills, my actual thing, which I work on Galaxy Evolution, is not valued by the industries, so they only seem to appreciate the machine learning or image processing. So maybe one of the things that industries can look into if they want to hire scientists from different fields is maybe give sort of like a 10% science time where I can promote my exploratory work, and then 90% time is for the industry. So sort of what is done in observing telescopes. So I wanted to know if this is feasible or if this is thought by the industries.
Anybody wants to respond to that? Raghu? Yeah, Mr. Raghu, please. Yeah.
This is a very personal take. I don't count number of hours. So when you say 10%, 90%, I don't know what the denominator is. I think the modern workplace has evolved to let you do what you need to, as long as you get done what needs to get done.
Your question is along the lines where you want to use the, let's say, equipment, labs, computation infrastructure of the company for a project that is not of the company. As long as it's not a significant OPEX, I don't think it will go basically unnoticed. It depends on the relationship with your with your reporting manager. But if it's something very significant where it shows up in the bottom line of our company, that is not going to happen. I mean, let's be honest at that side.
Okay, so what I suggest is, because we are getting into and the next session has to start at 2 o'clock. So if you have further questions, please, come forward and we can hang around here, few of us. And any last comment?
Yes.
Please.
So,
Yeah.
if I'm not wrong, TCS is opening up its PhD fundings this month. So it was supposed to come in February. So February has just started. So most likely they are going to come up, or they have already come up yesterday. So there are already opportunities, if I'm not wrong. So people who are interested, they can
Send the advertisement to ASI. We'll put it in our job register. Thank you very much. Thank you very much. I think it was a good session, and let's reconvene at 2 o'clock. Yeah.
Just quick.